This presentation discusses some of the groundwater issues surrounding the Hogan-Pancost property. For many of us in the area, groundwater is not an abstraction, it's a very real thing. Here's a picture taken on an adjacent property of a tree that had tipped over, showing in the hole the standing water. This is typical conditions in the area. We see groundwater even as shallow as 1 foot down. So there are a number of real core questions that don't seem to have either been well asked or answered. The key one is that will the development negatively affect groundwater levels? Will the development raise groundwater levels or increase the flow rates for the adjacent homes to the west and north of the property, thus increasing the risk of basement flooding? And secondly, will the development impact groundwater levels by decreasing the levels or flows to the east, where we have state designated natural area, important open space wetlands? So, of course, to answer that question, one would want to know, for example, where does the groundwater come from and what is its direction, depth, and rate of flow? Will the site excavation, all the construction of utility trenches and foundations and whatnot, will that affect groundwater flows across the property? The developer attributes much of the sump pumping problems in the area to leakage along Dry Creek Ditch number 2. How much leakage exactly is there along Dry Creek Ditch number 2, and is this leakage the cause of the sump pumping problems? Of course, we've seen over the last few years relatively dry years. However, what will the groundwater level be like on the property and in the adjacent homes in a wet year, and will the development affect the characteristics of that? And then finally, do the 2 groundwater reports submitted by the developer to date provide both correct and complete information to answer these questions with a high degree of confidence? And that's what we're going to talk about today. So the developer likes to think that they have a monopoly on, quote, factual analysis. Well, what we're going to do is actually look at the facts of the matter. Most of the material we're presenting today actually comes from the developer's documentation themselves. So the developer likes to have these pictures of the large groundwater area or the large watershed area, where they even say it's not possible for the development to affect local groundwater levels because it's only 0.03% of the total watershed area. Likewise here, they point out that the whole watershed is 84,000 acres, and yet Hogan-Pancost has only 20 acres, so what can they possibly do? Well, even at this large watershed level scale, there are some important aspects that aren't being noted. If we zoom in to the mouth of that watershed, we see that it's a very narrow mouth of the watershed. That full 80,000 acre watershed only flows through only a 2-mile narrow wide area. And furthermore, the Hogan-Pancost property sits right in the middle of that, right in the area where there is probably the most alluvial groundwater flow, right next to South Boulder Creek. And that it actually encompasses about 15% of the entire cross-section of the mouth of the watershed. If we take a little closer look, here we have a 1938 USGS topographic map that shows some of the original topography in the area. These are 10-foot contours. There's the Hogan-Pancost property. And then here's the Dry Creek Ditch. Turns out the settlers used an old alluvial flood channel of South Boulder Creek, as we see, to actually run the ditch through. And that alluvial flood channel actually goes right through the Hogan-Pancost property, as we see here. If we look a little closer and overlay this with a high-resolution digital elevation model from the city, again, we see that the actual surface flow direction is off to the northwest. This is most likely indicative also of the flow of groundwater. Here we have a map showing measured depth to bedrock that the developer did last summer. We, of course, have put this map together. What's interesting is that towards the east side of the property, we have incredibly shallow depth to bedrock, as shallow as 2.5 feet down. In the north end of the property, most likely the reason why there's some 14-foot and 13-foot is that that is where the prior property owner brought an extensive amount of illegal fill. So we have about on average around 10-foot depth to the impermeable pure shale. Now let's look at what we've measured so far. The developer has had a number of wells on the property since 2006. Unfortunately, they have only collected data for 2 seasons. Here we have then a plot that shows the 4 different wells and the depth to the groundwater in feet. What's interesting then is that on the left of the chart in April we have groundwater levels as shallow as 1 to 3 feet below the surface. We can see then the very quick rise in March and April. That's again the overall watershed feeding this area, plus the local irrigation. What's also very interesting to note is that on the right of the chart, starting in December and January, we have again groundwater levels just 1 to 3 feet below the surface, even in January. The bar chart at the bottom shows the precipitation for those same years. Again, we see we do have a number of precipitation events, but this was climatologically a relatively dry year. If we look at the locations of those monitoring wells on a map, again, we see that we have very shallow groundwater levels, 1, 2, 3 feet below the surface, across the entire property. Likewise, this is the chart from the second season of data they've collected, starting in May of 2011. What's interesting to note here is that we see the effects of the incredibly dry winter and spring that we had in early 2012. But again, we have groundwater levels 2, 3, 4 feet below the surface, even in a very dry year, the driest spring on record. Okay, so let's now look at a timeline of events in the area. So in the late 1960s, Keewaydin Meadows was developed. There was a number of floods throughout the property, but through that whole time there were no sump pumps on Cimarron Way to the west of the property. Throughout the 1970s and 1980s, this represents the typical conditions on the Hogan-Pancost property. The ditches were unlined, there was extensive flood irrigation, perhaps a pond typically existed 1 to 2 acres in size, a foot deep in the center of the property. Again, for those homes to the west, immediately west of the property, no sump pumps were required. But now in fall of 1989, the soccer fields were completed. 2 months later, that winter, 3 homes on Cimarron Way had basement flooding problems and all had to install sump pumps. They had decades of no problems. 2 months after the soccer fields are put in, they have problems. In September of '93, a fiber optic trench was dug through the backyards along Cimarron Way. A few months later again, a new home, 240 Cimarron Way, installed a sump pump. Second sump pumps were installed on those original 3 houses. Winter of 2001, the Dry Creek ditch was cleaned. A few months later, a sump pump was installed in a new home at 250 Cimarron Way. And then a few months later, another home had to have a sump pump installed. So something's happened here over the years. Finally, in 2008, flood irrigation stops and the lateral ditch was aligned because the development group bought the property with the expectation that that would solve the sump pumping problems. Still, no change in the use of sump pumps. People are still having problems. 2010, the new soccer field development was completed. Again, they actually had problems with groundwater and had to raise the soccer fields more than planned. More sump pumps were, second and sump pumps were installed in some of the homes. So this is not just a localized problem though. This map shows homes in the area that either have reported that they have sump pumps and have had sump pump problems, and shown in blue. The homes shown in yellow actually have had no problems reported. So we have over 40 homes in the area with active sump pumps. I personally have heard a litany of stories of people with flooded basements throughout the whole area, and not just along Cimarron Way. What's ironic is that one of the developers, Michael Boyers, once owned a home in Greenbelt Meadows and related once that his basement actually flooded once in the winter time at Christmas because his sump pump cut out. So now let's go look at what the developer has to say about the causes of this. Here's something they submitted to the city 2 years ago in their original submission. It shows the Dry Creek Ditch corridor along the west side. Notice the blue arrows along the whole stretch of the Dry Creek Ditch corridor, noting below ground ditch seepage. Furthermore, in their summary, they state that the number one issue is the high seepage from unlined Dry Creek Ditch number 2. So that's what they've stated all along. They've had this assumption that it is the flow of water along the ditch that's causing the sump pumping problems. So let's go look at what the developer has actually done. To date, they have submitted 2 reports. Both of these reports use analytical simulations. In this case, the first report, they use a model called ModFlow from the USGS. So here we have basically the grid that they model. The orange in the center of the grid is the Hogan-Pancost property. So it's a very large spatial domain. Some of the important parameters of this model or this simulation is how much recharge is coming in from these properties. In other words, how much water is leaking, for example, from irrigation or rain, into the ground. For the 20-acre Hogan-Pancost property, they estimate that there is only about 0.16 of an acre-foot per day total leakage going into the ground. For the Bowden property to the south, they note that it is 0.05 acre-feet per day of recharge. So from this and from another parameter called hydraulic conductivity, they run the model. Here's the existing conditions that they're modeling. That green line across the center represents the full stretch of the Dry Creek Ditch, number 2. So they run the model with pre-development conditions. They calibrate the model, though they don't describe the steps of calibration, based on 1 year's worth of well levels. And then the post-development results, the only thing they model here is a change to how much water, how much recharge is coming in on the actual Hogan-Pancost property. Notice then they come up with a conclusion that there won't be any effect on the groundwater levels in the homes in the area. However, just look at the raw scale. That little black rectangle represents one of the person's lots, not just their home, but a lot. And now they're judging, they're making conclusions that the development of 137 homes will not affect the groundwater levels underneath those homes right there. And again, they make a very strong conclusion based on a single simulation run of a single model. That is, they state that the most important conclusion is that development can only lead to a decrease in sump pumping in nearby residences. That's a pretty strong conclusion from purely a single run of a model. Let's look at the second report. They submitted another report in 2012, and this time they ran a different model. The intent of this report was to quantify how much leakage there is along the Dry Creek ditch. Again, to rationalize that if they can pipe the ditch and do away with the leakage, then it'll also do away with the sump pumping problems. And so in this case, they have a little more detail. They're modeling the sump pumping withdrawal rates from the homes to the west. That's a very, very rough estimate based on the measurements from one home. They're also modeling the sump pumping from the Bowden property. There's 4 sump pumps there, again as a withdrawal. They also include some spillover from the lined Bowden lateral to the north, a small amount of spillover. And then somehow they've come up with 64 gallon per minute leakage rate from the ditch. So how do they do that? Well, it turns out that that is purely the modeled value. Never once have they actually measured the flow rates along the ditch itself. So all of the results to date, the only actual measurement that has gone into the results in both of these groundwater reports is 1 season's worth of well logs. They have never once done measured flow tests. They have never measured the actual amount of water that flows along Dry Creek ditch, either entering the property or exiting the property. And they have never measured actually through, for example, dye tests where that groundwater is flowing across the property. So again, they have a very strong conclusion from this report. They state that there are simply no mechanisms associated with the development that could cause the summer pumping rates to increase. Well, that's what the developer has produced over the last 6 or 7 years. 2 reports, both of them 100% based on an analytical simulation. Both of those simulations are from a single parameterization of the area, and furthermore, they do not include error estimates, confidence intervals, or have they done any form of sensitivity analysis. So that's what the developer has stated. So now let's actually look at the facts of the situation. 1, models are only as good as what they're modeling. So let's see. Here we have then the main stem of Dry Creek Ditch number 2. It has a decreed amount of 19 cubic feet per second. That's the total amount of water it could take. However, over the last 3 years, based on records from the state, at the head gate on South Boulder Creek, the Dry Creek Ditch has averaged 7.8 cubic feet per second throughout the irrigation season. Now, the dashed blue line shows that stretch of Dry Creek Ditch number 2 rarely, if ever, flows. Perhaps there's a small amount of water that flows through there 1 week or 2 weeks out of the year when there's call for water to the north of this property. Furthermore, the stretch of Dry Creek Ditch along the Hogan-Pancost property itself usually exhibits minimal flow. So the question is where's all this water going to? Well, it's a fairly complicated irrigation hydrology in the area. 1, there is, well, let me step back. Again, the developer always states that it is the ditch, that's leakage, that's causing these problems. So there is a diversion ditch right at South Boulder Road that diverts water along South Boulder Road and to water open space properties east of South Boulder Creek. And that's about, the city owns about 35% of the shares of that water. So where does all the other water go along the ditch? Well, the Bowden lateral ends up being where most of that water flows throughout the irrigation season. C.D. Bowden and Joe Kent are longtime property owners in the area, and they do extensive irrigation on their properties. The neighbors, myself included, all support this decades-long irrigation practices. The irrigation water that those two property owners bring in plays a critical role in the environment and the aesthetics of the area by fostering all of the growth and the wetlands. So this presentation is not meant to criticize any irrigation practices, but rather it's meant to purely document how much water is being brought in on this property. So the Bowden lateral gets the lion's share of the water along Dry Creek Ditch number 2. Furthermore, there are a number of other water rights these property owners have. We believe there's something called, quote, Froggy Gulch water, which is decreed amount of 2.5 cubic feet per second. There's also Hogan Seep water. There's a sump and a pump in the Veely Channel that brings water into that lateral ditch. Also on the east of the property, there's also another pump as well. So all that water comes into the property, and now we're going to take a closer look at where it goes. Well, there's the main stem of Dry Creek Ditch number 2. It's dry most of the year. Here we have the lateral along 55th, and that feeds into the lined lateral along the south side of the Hogan-Pancost property, the Bowden lateral. There's also a pipe that feeds in the center a pond. The overflow of that pond again flows into that lateral and to the west. On the west side of the property, there's actually a diversion into a sump. The intent of the irrigation here, the intent of this water, is to recharge the groundwater. This property owner irrigates by shallow wells. They bring in water from the ditch, they recharge the groundwater, and then they pump to irrigate. There's a small amount of overflow from that ditch that goes back into the main stem of Dry Creek Ditch number 2. Furthermore, again, we have the pump and hose that brings water to the west side of the property, and there are 4 sump pumps. In the developer reports, they treat these sump pumps as withdrawals of groundwater, but what actually happens is those sump pumps flow into the ditches, which then moves that water to the west to recharge the groundwater on the west side. So in essence, much of this water that's brought in is actually concentrated on the west side of the property. Now, if we look at what the developer has reported in their new report, all they state is that, quote, water also spills over a portion of the ditch lining and recharges the groundwater system. This is odd that they don't actually describe what is going on, considering that the developer paid for and constructed the lining of the ditch as well as the diversion dam that diverts that water into the west side of the property. So, how much water is actually being brought into this area? A conservative estimate looking at both the ditch flows as well as looking at the geometry of the ditches themselves, we come up with anywhere from 5 to perhaps 10 acre-feet per day of water is being brought into this area. And furthermore, the intent of that is to recharge the groundwater by design. So most of that is probably groundwater recharge. Now let's see what the developer stated for recharge in these areas. In their first report, you will recall, in their model, they have the recharge rates for this property in total to be only 0.05 acre-feet per day. In their second report, that little spillover on the Bowden lateral, they attribute recharge from that to be only 0.02. So what we have here is they're off by a factor of 200, perhaps up to 500 in their estimates of recharge rates. That's almost 3 orders of magnitude difference between what they're modeling and what the ground's actually doing. So now let's take a look at this property from another perspective. Here we're looking from the north to the south. Again, we have water being brought into this pond area. We also have then the Bowden lateral, the lined lateral into this sump area in the back. There's a small amount of overflow along the main stem of Dry Creek Ditch. So what we end up having is a large amount of groundwater being brought in onto the site, and that groundwater, of course, is flowing north or northwest from the property. And then this is actually the homes just northwest of here that have had sump pumping problems. Again, we're not blaming anyone here. These are decades-long irrigation practices. Our major concern is what is going to happen to that flowing groundwater when we bring in 137 homes in the area with the thousands and thousands of linear feet of utility trenches, all the site excavation work, the foundation walls, all of this intrusion into a very shallow alluvial area that has a large amount of groundwater flowing through it. One of the problems we have with the groundwater reports, other than their overall approach, is not once do they ever mention construction impacts on groundwater flow. So to recap, in the end, we believe that all of the parties involved, the third-party reviewers, the city engineering staff, planning board, and council, needs to agree with a high degree of confidence that the developer's groundwater reports, 1, follow all standard industry best practices, 2, are correct and complete, that they accurately and completely describe the hydrology in the area, and then 3, they need to definitively show that this development will in no way either increase groundwater levels under the homes on the west side of the property or lower groundwater levels on the wetlands to the east. Furthermore, we ask, do the third-party reviewers and the city engineering staff agree with the report's conclusions? That is, that there are simply no mechanisms associated with the development that could cause the summer pumping rates to increase. Thank you.